Hi, everybody. Welcome to Lesson 3 for Level 1 Dosage Calculation. The topic for today is dimensional analysis, which is a systematic method for accurate unit conversion. And this is the type of dosage calculation that you're going to be taught here at Western. It is the safest, and it's backed by research and evidence, and it's we're only going to teach you one way, and you're going to use it for everything all the way through your whole nursing school experience. So as you look at the slide before you, you'll see that there's a balance there, and it's a really good image to get into your mind because what we're doing is we're going to start out with one fraction to the left side of the balance and imagine there's an imaginary equal sign between the two. And then there's going to be a fraction on the right side, and you're going to continue to build your equation to the right. And I'm going to explain to you exactly how to do that today. And I want you to think about it as pattern building. Try not to think too much about math just yet. Think, what pattern do I need to set up? I'm going to teach you how to set up your pattern today. Okay, so the first part is pretty basic. All right, I just want you to focus. You always have, or almost always have, a number, which tells you how much, connected to a unit, which tells you of what. Okay, what is it that we're measuring with that number? And again, dimensional analysis is a practical scientific method used to solve mathematical equations by emphasizing the units of measure. This whole pattern game is all about those units of measure. So we've been talking about labels, and you've been working on decoding this language. So those labels are in the column to the left. The new thing today is dimension. Dimension is the physical property being measured, whether it's mass, volume, length, time, whatever. That's your dimension. On the right, though, let's talk about some of these mechanics of what we're going to be doing. So the equation is just a math sentence, and that's what we've started teaching you how to decode, okay? It shows two equal sides functioning perfectly like a balance with an equal sign in the middle. Factors of measurement are data, numbers, units entered into an equation in fraction form, okay? Numerical orientation is the number specific placement. Okay, so today we're going to be talking about numerators and denominators of a fraction. And in the example on the screen, the top number, 12 inches, is the numerator, and 1 foot is your denominator. And you're going to hear me refer to numerator and denominator. Conversion factors are a very core part of what you're going to be learning in this system. A conversion factor is a ratio written in fraction form that converts one unit of measure to an equivalent numerical amount in another unit, okay? It's like a bridge that gets you from one place to the other, okay? So, for example, if you look at the first one, for every 1 yard, there are 3 feet. That makes sense, right? You guys learned that back in school. Um, Another one, 1 gram is equal to 1,000 milligrams. Remember those cards that we gave you with your metric conversions on it for dosage calculation? Hopefully you've got them memorized by now. That's where these conversions are going to come into play. And you're expected to have them memorized and be able to pull them up when your equation tells you you need one. And I'll show you how your equation is going to tell you that. Every equation requires 3 foundational elements, okay? The desired answer or unit. So remember when we were decoding, and one of the things we looked for is what is the question asking? So you need to know, what is the desired question unit of measure? Is it milliliters? Is it milligrams? You need to know that first. You need to know the given quantity and units. That's the starting raw material that needs to be converted. And conversion factors, and that's what we gave you on your cards. The engine that transforms the given unit into the desired unit. The method takes a known quantity and multiplies by one or more conversion factors to solve the equation. Like I said, this is a pattern, okay? And we're going to teach you that pattern. Always build your equation from the left to the right. So the first thing we're going to put in to the left of the equal sign is the desired target unit. And right now I'm just giving you all the pieces of the puzzle. Then I'm going to demonstrate for you how to put these puzzle pieces together, okay? Then you have an equal sign. Then we have a fraction bar. And the numerator of that very first fraction past the equal sign is where you're going to put that very same target unit of measure in the top, okay? And then that will tell us what to do next, and I'll begin to show that to you. One of the core principles to dimensional analysis is cross cancellation. Now, in this type of dimensional analysis, we are only cross-canceling units of measure, okay? And I'll show you what that looks like in the computer in a minute. So your unit of measure will be on the right-hand side. So pretend this one says milliliters, and milliliters is up here. I can then cross them out because they match crisscross ways, okay? That's how you know you can cross them out so that they're eliminated from your equation. That's a really important principle, and I'll be demonstrating it a lot for you. For example, you have a problem, and the problem is asking you how many inches are in 2 feet. Now, of course, you probably know this right off the top of your head, but that's not the point. We are starting you at a very basic level to teach you how to set up this pattern when it's easy, so that when it gets much more complex, and believe me, it will, I'll show you one later, you will have that understanding of how to do this, okay? So, what did it ask for? It asked for, it asked how many inches. How many inches are in 2 feet? Okay, so what it's asking for is inches. So that goes in the numerator of our first fraction to the left of our equal sign, okay? Then we build a fraction on the right of the equal sign, put your fraction bar in. The top numerator is also going to be inches because these two have to match. That's your logic. Inches equals inches, correct? Correct, okay? So now you don't always need a conversion factor in your first fraction. That's not a part of the pattern. You may have to put in a conversion factor, pardon me, in any point of your equation. It just happens to occur first here, and you may find that's common in the beginning when we're teaching the basics, okay? So this conversion factor is there are 12 inches in 1 foot. But the question is asking me how many inches are in 2 feet, okay? So now I have foot on the bottom, foot and feet equal the same thing, okay? So up here, I also have to have foot or feet in the top of the next fraction so that I can cross them out. So the question then has 2 feet. It wants to know 2 feet. So I put 2 feet on the top. Foot and feet are the same word. So it cross out foot, cross out feet because they crisscross match. Okay. Inches is not matching anything to the right of this equation. And besides, we want inches. That's what we want in our final answer. So it's okay that it's left standing. All right, so now I can say to myself, I've crossed out everything I could possibly cross out. Now all I have to do is the math. The way we do the math for dimensional analysis is to the right of the equal sign, you're going to multiply all of the numerators together first, okay? So 12 inches times 2, 12 times 2 is 24. 1 times 1 is 1. Then you're going to divide the numerator of this fraction by its denominator. 24 divided by 1 is 24. The only unit of measure remaining is inches, and that's what we want. 24 inches is your correct answer. And here are a few more examples of how we do these conversions. And it just so happens in this example, all your conversion factors are occurring in the first fraction, but it's not always going to be that way, okay? All right, so if the question is convert pounds to kilograms, 110 pounds is how many kilograms? They're asking for kilograms, so kilograms is going to be, this is technically in the numerator position of the first fraction before the equal sign. If it's there, you also have to have kilograms in the numerator of the first fraction past the equal sign. Kilograms equals kilograms. I've set it up correctly so far. Okay, so I need to move from kilograms to pounds, and that's all I have to do in this problem. So I know I have to have a conversion factor in here. Okay, so the conversion factor for weight is 1 kilogram is equal to 2.2 pounds. Now I have pounds on the bottom, which means I must put pounds on the top of the next fraction. All right, well, how many pounds did it say? 110 pounds. I put 110 pounds up there. I can now cross out pounds and pounds. The computer got a little crazy crossing everything out. We're not crossing everything out, just the unit of measure, okay? Now I'm done. There's nothing more I need to put in there. 1 times 110 is 110. 2.2 times 1 is 2.2. So you multiply across your numerators all together, multiply across your denominators all together, get your final fraction. 110 divided by 2.2 is equal to 50. And then you say to yourself, 50 what? 50 kilograms, because that's what your question is asking you for. And you crossed out all the other units of measure, so that all that remains is kilograms. So that's my check, double check, I did it correctly. The one last thing that you need to do is ask yourself, does this make sense? So when you're calculating, you will have to always look at your final answer and say, does that make logical sense? Because if it doesn't make sense to you, then you need to go and get somebody with more experience than you. So that's not another student nurse. It's an RN, a preceptor, an instructor, to look at your work. And who knows, it may be that you did it right. It's just that it's such a big number, it doesn't feel right. Okay. And they'll reassure you and show you that you did it right. Or they may say, hey, great catch. Yeah, you had your math wrong. This is where you went wrong. And they'll explain it to you. And this slide is just another example of how these different conversions go. If you have your phone out, you can take a picture of it, because it's a nice example. It might help you later. We're also giving you a study guide today, and that will be very helpful too. So here's an example, a real world example of something you're actually going to be doing when you go into your clinical rotation this term. It's adding up your patient's intake, okay? So if your patient had a third of a glass of apple juice today, that's equal to about 3 ounces. If your patient had a half a cup of coffee, that's equal to about 4 ounces. And the patient had a half a pint of milk, that's about 8 ounces. So your total is 15 ounces, okay? But your charting requires you to chart it in milliliters. So you need to convert that over into milliliters, okay? So now you've created your own question. Well, how many milliliters is 15 ounces? So your first unit of measure is milliliters. Equal sign. Numerator must be milliliters, so they equal. Milliliters equals milliliters. All right, well, I'm not there yet because I have 15 ounces. That's what I need to figure out. Okay, so now let's look at it. All right, so I need a conversion factor. 30 mLs is equal to 1 ounce. So 30 mLs goes on the top, 1 ounce goes on the bottom. Oh, that's great, because now I've got ounces on the bottom. That means I have to put ounces on the top of my next fraction. And what I want to know is 15 ounces. So I can put 15 ounces on the top of my second fraction. And then I'm done. You can put an invisible 1 underneath because that helps keep you straight. Now I can cross out my ounces and my ounces because they crisscross. Now let's do the math. 30 times 15 equals 450. And yes, you may use your calculator for this. You will always be provided with a calculator, either in the computer or we provide them in class. You don't use your phone for this. 1 times 1 is 1. Now you divide the numerator by the denominator. 450 divided by 1 is 450 mLs. And that's what I can enter into the computer now for my patient's intake. Now here's another one, and for the brave souls out there, give it a try. See if you can do it. If the answer is up on the board, but let's see if you can do it. So your patient or client drinks a 3/4 cup of tea and a 1/4 glass of orange juice for lunch. Convert all intake into milliliters. All right, you have known capacities. 1 cup is equal to 8 ounces, and 1 glass is equal to 6 ounces. So 3/4 of a cup is how many ounces do you think the patient took in? And 1/4 of a glass is how many ounces? And of course, the little symbol to the left there tells you what that is. And your total would be 8 ounces. But now the question asked you to convert it into milliliters. So set up your problem. What's going to be your first one before the equal sign? Milliliters, because that's what it's asking you for. Milliliters equals, so on the top of the second fraction must be placed milliliters. Now you have milliliters equals milliliters, but we need to know how to get to ounces, so you need a bridge. That's your conversion factor. So 30 ml is equal to 1 ounce, so that's my conversion factor. If I have ounces on the bottom of the first fraction, I must have ounces on the top of the second fraction. So that's in there. Cross out my ounces. Invisible 1 under that 8 ounce. All right, do your math. 30 times 8 is equal to 240. 1 times 1 is equal to 1. 240 divided by 1 equals 240 mLs. So that's what I can record for my patient's lunch intake. In dimensional analysis, the cross cancellation guarantees and validates your math, okay? The golden rule of accuracy: if your units of measure do not perfectly cross cancel to leave only the desired answer unit, the equation is set up incorrectly. That's a clue for you. I set it up wrong. So go back and try to figure it out again, okay? And your key takeaway from this is when the 3 core elements are properly aligned and numerically oriented, the system guarantees an accurate unit conversion every time. That's what makes dimensional analysis safe. And we want you all to become very safe nurses.